Hello, Mr. Sutton here with the IM3 Honors 4-5 Extra Practice number 2 solutions on graphing quadratics. To graph this quadratic equation in standard form, we're going to start by finding the vertex using negative b over 2a. That'll give us the x value of the vertex. Our b value here is this 4, the coefficient of x. So this is negative 4 over 2 times the a value 2. So that's negative 4 over 4, which is negative 1. And to find the y value, we just plug that back in. So let's see here. This is negative 1 squared. That's 1 times 2 is 2. We're subtracting 4 from that, so that's negative 2. Minus another 2 gives us negative 4 total on that one. So we have the vertex negative 1 comma negative 4. That's going to be right here. They already labeled the graph for us. And now we're going to find two other points. One of which I'm going to use the y-intercept. That's this c value, this constant here, of negative 2. So that's the point 0 comma negative 2, and that is right over here. Now, since parabolas are symmetrical and our axis of symmetry goes through this vertex, that means there's another symmetrical point, one away from the axis of symmetry on the other side, right here, that I can use. And then I'll just draw my parabola through those 3 points. To graph this parabola in standard form, let me use negative b over 2a to find the vertex. So that's going to be negative 6 over 2 times, we have an invisible 1 for the a value there. So negative 6 over 2, which gives me negative 3. And then I'll plug that back into the original here for x to find the y value of the vertex. So we have negative 3 squared, that's going to be 9. We're subtracting 18 from that, so that's negative 9, but then adding 9 gives us 0. So negative 3 comma 0, that's my vertex, and that is right here. Next, I'm going to get the y-intercept for another point. That's 9, that's this constant right here. So that's all the way up here. My y-intercept, 0 comma 9. And then using symmetry, since this is 3 away from this axis of symmetry going through the vertex, that means there's a symmetrical point 3 away in the other direction right here. And now just draw the parabola through those 3 points. For this multiple choice question, we want to know which graph here could represent this function 2x squared minus 2. Now, you can't just plug in points that they gave you on these graphs to the equation here to test it out because there's no scale on these graphs. So we really just have to go by how the basic shape is. Now, one thing to take note of with the original equation here, we have a positive a value. So that means that this should be a parabola that opens upwards. And it looks like then we have 3 choices that open up, A, B, and C. But we can eliminate D right off the bat because it is not an upward opening parabola. The only other piece of information here is this negative 2. That gives us the y-intercept. And if the y-intercept is negative 2, that means at the very least the y-intercept for our parabola has to be below the x-axis. So taking a look at our remaining answer choices, A is above the x-axis completely, so there's no way that has a y-intercept of negative 2. B, well, this could be negative 2 down here, so B is still in the running. C, no, not so much. This touches the x-axis right here. The y-intercept is all the way up here, though. So only choice B has a y-intercept that could possibly be 0, negative 2. For this problem, they're saying if this equation here is written in the form y equals a parentheses x minus h squared plus k, what are the values of h and k? Now, I gave you a hint on this one that h comma k is the vertex. So basically, this is this special vertex form that you would get by completing the square on this. But you don't actually have to do all the work of putting this equation in this form to figure out h and k. To figure out h and k, you really just need to figure out the vertex of the equation they gave you. And since that's in standard form, we start by getting the x value of the vertex with negative b over 2a. So that's going to be negative 18 over 2 times 3. So that's negative 18 over 6, which is negative 3. And that at least narrows it down to choices B and D, where h is negative 3. Now to get the k value, that is going to be the y value of the vertex. So that's going to be basically just plug negative 3 back into this y equals equation up here. So we've got, let's see here, negative 3 squared is 9, times 3 is 27. 3 times 18 is 54, so we're subtracting 54. 27 minus 54 is negative 27. Negative 27 minus 13 is negative 40. So that's our k value, negative 40. So that's going to be answer choice B. If you have a vertex of negative 3 comma negative 40, choice B. For this problem, the graph of y plus 3 equals x minus 4 squared minus 6 is a parabola in the xy plane. Well, we can see that it will be a quadratic once we square this x here, so yeah, that makes sense. This is actually almost in vertex form for parabolas. We want to know the x-intercepts of the parabola. So you actually don't need to know anything about vertex form to find the x-intercepts. The x-intercepts of any function happen when you're on the x-axis, which is to say when the y value is 0. So all we have to do here to find x-intercepts is plug 0 in for y and then solve for x. Okay, well, we've got basically 3 on the left side. Let's add the 6 over there to get this squared stuff isolated. So we have 9 equals x minus 4 quantity squared. And then since I just have a square and a 9 over here, I can square root both sides. So that'll be x minus 4 equals, and don't forget we have a plus or minus square root of 9. So plus or minus 3. And then to isolate x, I'll add 4. So that'll give me 4 plus or minus 3. And it looks like the answer choices have actual numbers instead of one of these plus or minus deals. So we just need to subtract 3 and add 3 to get our two different answers. 4 minus 3 is 1. 4 plus 3 is 7. So 1 and 7, choice A, is our answer. For this problem, we're given this graph of a parabola, 2x minus 4 times x minus 8. So this is a parabola in vertex form, and we want to know which of these 3 statements is true. And it looks like more than one of these could be true, so they're not mutually exclusive. So we're just going to go through each of them and, test each of them out. So for this option 1, graph's line of symmetry is x equals 5. Well, the line of symmetry is just the x value of the vertex, or at least it's on that x value. So let's start by finding the zeros here, and then we can use those to get the vertex. So my x-intercepts is going to be whatever zeroes out each of these factors, because if you set this whole thing equal to 0 and solve, you're basically zeroing out the factors, and that gives you the x-intercepts. So for this first one, so adding 4 and dividing by 2, we've got an x-intercept of 2 for that first one. This next factor gives us an x-intercept of 8. Now, if I add those together and divide by 2, if I average them, that's going to be, let's see, 10 over 2, which is 5. So the line of symmetry goes through the vertex, and since the vertex x value is 5, the line of symmetry is also 5. So this is a true statement. Moving on now, the minimum value of the graph is negative 7. Well, the minimum value is going to happen at the vertex. It could be the max value as well. The vertex is where everything turns around. It's either at the top of the parabola or the bottom, depending which way your parabola is facing. Now, since this parabola has a positive out in front, this parabola opens upward, which means that its vertex is going to be at the bottom of the parabola. So if you want to find the minimum, just find the y value of the vertex. Okay, well, we've got the x value of the vertex right here. It's 5. So to find the y value, we just need to plug that 5 in for x in the original equation. So we'll have 2 times 5 minus 4 times 5 minus 8. So just finding the y value of the vertex. So this is 10 minus 4, which is 6. 5 minus 8 is negative 3. 6 times negative 3 is negative 18. Negative 18 is not the same as negative 7. So this is a false statement that the minimum value is negative 7. It's actually negative 18. Okay, on to option 3. The y-intercept of the graph is 32. So one way you could do this is FOIL this out, multiply it out, and see what the constant is after you do all that. And if you do that, you will see that it's 32. Another way you could do it is just plug 0 in for x directly into the equation, because the y-intercept happens where x equals 0. Because on the y-axis, that's an x value of 0. So if I plug 0 into the original, this ends up being negative 4 times negative 8, which again is 32. So this is a true statement, which means that statements 1 and 3 were true, which means choice B is what we're looking for. For this problem, we've got the graph of some quadratic function f, and minimum point shown at 1, negative 2. Basically, what they're telling you here is that the vertex is at 1, negative 2. And the really important piece of this is that the axis of symmetry is at x equals 1, which you can kind of tell from the graph, but they're just really spelling it out for us in case you didn't trust the graph. Now they're saying if f of 5 equals f of c, they want to know what c could be. Well, let's take a look at f of 5. F of 5 is the y value you get when you plug in 5. So taking a look at 5 here, if we plug that in, we appear to get a value of 6. In any case, though, the important piece here is that 5 is 4 to the right of my axis of symmetry. So using symmetry, since 5 is 4 to the right of the axis of symmetry, that means if I plug in whatever x value is 4 to the left of the axis of symmetry, then I'm going to end up with this c value. I'm going to get the same output as I do when I plug in 5. So we need c 4 to the left of the axis of symmetry. The axis of symmetry we said is 1. 1 minus 4, that's how you find 4 to the left. 1 minus 4 gives us negative 3. And if you take a look at this graph, because they did give us a picture, the output from 5 looks like it's 6. If you plug in negative 3 for x, that also looks like it's giving us 6. So everything is pointing to negative 3 being our answer on this. For this problem, they're telling us in this quadratic function, which they're giving us these mystery constants of a, b, and c, they're saying a and c are both negative. So based off of that, just using the basic shape of the graph, which of these could be the graph they're talking about? Well, let's take these one at a time. If a is negative, then that means that my parabola must open down. So that eliminates choices b and d, which both open up. So those would have positive a values. So we're down to a versus c, choices a and c. Now they said the c value is also negative, less than 0. Well, that means that my y-intercept is negative. My y-intercept is below the x-axis. So between choices a and c, which one has a y-intercept below the x-axis? That would be choice c, has the y-intercept down here. So choice c must be our answer.